again. So the best way to kind of remember this, one way that I used to teach it was the restrictions for tangent of theta and sine of theta. The angles have to fall within here. So when you guys are drawing your angles, they have to fall within here. You can't have your angle go like outside. That was the problem with the 7 pi over 4. It went outside of the restriction, right? That's why I had to use the negative version of the angle. So when you're if you want to draw the angle for your answer, make sure it falls within the restriction. For the cosine, the angle has to be drawn within that restriction. You can't go outside of it. OK? So now we have tan inverse of cosine of pi. So again, we figure out what is the cosine of pi. Well, pi, we know that angle is over here. So if we were to look at the unit circle, if to the right is 1, 0, well, then over here is going to be negative 1, 0, right? So what is the cosine of this point? Right? That's a point on the unit circle. So we can say cosine is equal to negative 1. Does that make sense? OK. So we'd say tan inverse of negative 1. So now what we're looking for, Trinity, is we're looking for the angle when the tangent is equal to negative 1. We're looking for when tangent is equal to negative 1. So again, I refer you to that first quadrant. Remember, tangent is y over x, right? Forget about the negative 1 for a second. What is the only coordinate point where you do y over x and you get 1? What is the only angle that produces that coordinate point? 45. Pi over 4, right? Or 45 degrees. When you look at pi over 4, 45 degrees, the coordinates are square root of 2 over 2, comma square root of 2 over 2. That's the only one. When you do y over x, you get 1. Correct? Yes. OK. So now, that's not the answer, though. That's just a way for us to understand. Here's that point. Square root of 2 over 2, comma square root of 2 over 2. When you do y over x for that coordinate point, though, you get positive 1. So I want you guys to start thinking about reflections. We know that angle, that gives, that's pi over 4. So let's reflect about the y-axis. Right? So now it's negative square root of 2 over 2, comma, square root of 2 over 2. Does that produce a negative 1 when you do tangent? Yes. So that one, that's a possibility, right? Then let's reflect that over the x-axis. So you have negative square root of 2 over 2, comma, square root of 2 over 2. It is both negative. I just didn't write it lights. Does that produce a tangent negative 1? No, that one doesn't work, right? So cross that one out. Negative over negative is a positive. We're looking for negative 1, right? Then we have this one. Reflect this over the x-axis. You have square root of 2 over 2, comma, negative square root of 2 over 2. Does that produce? Yes. OK, cool. However, what is the constraint? So we're looking for the angle, right? We're looking for the angle that falls within the constraint of negative pi halves to positive pi halves. So we know this one doesn't work. We know this one doesn't work. Forget about the angle. What is the only coordinate point that has a terminal side that lands in there? This one, right? This one doesn't work. So if we go up to go to pi over 4 over here, how far do we need to go down for this one? Done. Answer. OK?